Okay, so the record has started, and today I'm going to make a presentation about the OpenXR and augmented reality in HoloLens 2. And my name is Michael. I'm a .NET developer. I am currently located in Poland, Łódź, and I'm playing electric guitar time after time. And you can reach me out, ask any questions about the topic or any other things. So today's presentation about the OpenXR, it has three major sections. The first section is the OpenXR itself. The second part is the WebXR with Babylon.js example on HoloLens emulator. And the third part is the HoloLens. We will have an overview of the technology. We'll look at the business cases. We'll look at the example built in the Unity editor, and we'll discuss Azure integration services, integration of the Azure services. So I have made this presentation actually for my company that I'm currently working for, and there were three questions. How can we do it? Is it possible to do those kind of augmented reality or virtual reality applications at all? What are the competencies are needed by the developer to develop such an applications? And how those applications can be sold to the customers? What is the value of those applications, and how we can apply those XR applications to bring value to our customers? So OpenXR is a protocol, an API, and a runtime. It is cross-platform and it is future-proof. It is cross-platform for a number of the devices that use the augmented reality or virtual reality. And those devices are like HoloLens, Oculus devices, PlayStation VR, Android, Valve Index, HTC Vive, and many, many others. OpenXR is the technology that is supported by the major players such as Microsoft, Unity, Unreal Engine, Valve, Meta, Google, HTC, and other. And as I have mentioned, it is cross-platform, so you can build your application only once, and it will be run on many of the devices. And yeah, basically all the platforms that support OpenXR will support your application, and you don't have to manage a lot of the devices. So OpenXR is also future-proof. So if your application is built with using the OpenXR, then the future devices that will have basically different kind of input or different hardware, various hardware, then your application will work at those devices as well if they support OpenXR. Unfortunately, Apple does not support OpenXR, but they neither had said that they will not support it at all in the future. So they haven't denied, they haven't approved OpenXR. So we'll see how it goes for the Apple with the OpenXR in the future. So what is the problem that was solved by the OpenXR? So on the left, you can see that we have a number of the applications and the number of engines, the editors with by which we can build those XR applications. And you can see that there is a pretty messy diagram because you had to use different builders to build applications to different platforms, and then you had to build each of the application to a certain device. So it was pretty messy. And if you will look at the diagram on the right, you can see that the problem is actually solved, and OpenXR makes it really nice. So you have your application you use, for example, the Unity engine, and now you can build it, the application for a number of the platforms by using the single engine, and then your application can be deployed to any device that supports OpenXR. And today we will look at how to build those applications by using Unity, by using WebXR technologies, and we will use Microsoft Mixed Reality Toolkit to build an application for the HoloLens 2 device. So the WebXR. WebXR stands for Web Extended Reality, and the technology is pretty awesome because basically the idea that you use it for VR and AR applications online. This technology is supported by the W3C, and the idea is basically that you have a link. You do not have to install any app. You just use the link. You go to the website. The website will download the application into your browser. And there you have access to your devices, sensors and cameras and hardware. And basically you can use smartphone, computer, or headsets to access any application built online, right? So those applications are compatible with Chrome, Firefox, and Edge browsers. Unfortunately, Safari does not support OpenXR, and thus WebXR does not work in Safari. But we'll hope for the best, that the Apple will agree to use OpenXR in the future. So actually, yeah, you use WebXR, and the browser gives you access to the motion sensors, cameras, and the hardware of the device. You use just a simple JavaScript and HTML languages to build those applications with the help of Babylon.js and 3.js. So Babylon.js and 3.js, this is how the development is done, and those are two libraries that allows you to get the access to the WebXR features. Let's compare those libraries. Babylon.js is a high-level 3D graphics library. It is feature-rich. It has a simplified development, and it is backed by Microsoft and their documentation. On the other hand, 3.js is a low-level 3D graphics library. It supports custom shaders. You can program your beautiful graphics, detailed graphics. It is plugin rich, and it has a large community. So now we will look at the Babylon.js example. We will look through the code. We will see how the computer browser renders the Babylon.js applications, how the HoloLens browser renders those applications, and then we will go into the immersive experience of the HoloLens application. Okay, so Babylon.js code. You can see that this code snippet is actually nothing but the plain HTML with the JavaScript in it, and you can see that the first arrow points to the CDN Babylon.js library. The second arrow points to the script tag where JavaScript actually starts and renders in the loop each of the frames. So this is the part where the Babylon.js engine starts. And actually, the application is a piano that you can play. You can tap the keys, press the keys, and you will hear the sound. And there's a huge chunk of code that describes the piano. But actually, what I want you to understand and see here is how the WebXR is leveraged in this code. And you can see that the first arrow is pointing to the XR helper, and the second and the third arrows are pointing to the WebXR feature that is called pointer selection. So we are adding the pointer selection from the XR devices into the scene. And the last two arrows are pointing to the WebXR feature that is called teleportation, which is pretty useful because if you have a huge VR scene and you want to get somewhere in this scene, you don't have to like physically go all the distance. You can just teleport yourself on the scene. So this is a pretty useful XR feature. Okay, so an example of the Babylon.js application. So you can see that on my computer there's There's just a piano. This is a simple browser. If I press those keys, then I hear some sound. Okay, so I can engage with this piano on the scene. Yet this is the simple application. You can see that this is the index HTML file that I just opened from my local directory. Okay, but if we are going to look at the situation on the HoloLens emulator, and this is the HoloLens emulator, you can see that some of the applications are floating in the air. If I will tap somewhere in the space, you can see that we're actually are somewhere in the room. Yeah, and we can come closer to the application, Babylon.js application opened in the Microsoft Edge on the HoloLens browser. And you can see that there's just the same kind of browser simple application with the piano where I can engage with the piano and I can press the keys and play on the piano. But there's nothing special, right? So, but oh, by the way, this is my hand. This is the way of manipulating the objects in the HoloLens, right? So nothing special, but you can notice that on the bottom right there is an icon of the VR glasses. So if we're going to tap these glasses, we're going to get a message in the browser asking us if we want to allow the immersive experience. And if we will allow the immersive experience, we will see that the scene is going to change. I hope that is going to change. I'll tap at it once again. Okay, so something is happening. Okay, so the scene has changed, and you can see that we are actually present on the scene with the piano, and this is no more just a browser application inside of the browser. This is the browser application, and we are on the scene inside the app, so I can come closer to the piano, and I guess I can move my hand to play some keys. So you can see I'm tapping on them, and you can see that there's something appeared at the background of the piano. And actually, if I press the pointer tab somewhere in the scene, then I will see the teleportation feature. I'm trying to see the piano, so you can see that I have tapped the teleportation, and now I am away from the piano. Now I'm going to teleport closer to the closer distance to the piano, so you can see that I'm teleporting. You can see that those are the features that we have implemented in the WebXR application. So there's another example of the WebXR with the 3GS. You can visit xrdinosaurs.com, and if you have an Android device that supports the XR features, then you can place some dinosaurs somewhere in the space and in your room, and you can sort of see that there is a dinosaur with augmented reality on your phone, so you can look at it from the different angles. But unfortunately, my company wasn't interested in researching WebXR because this is basically the front-end technology, and I have provided research for the .NET division, and we want .NET and Microsoft-related technologies, not the JavaScript and front-end libraries. So because of this, we have decided to switch to the investigation of the HoloLens 2. And you can see the device on the right, and I will play a video for you to look at how the device works. So basically, there is nothing special in the video except that there is a person who uses all the kind of application and features of the device. And by the way, we can see from the camera the same experience that the user has in this device, because there is a technology called Azure Remote Rendering and Azure Spatial Anchors. So you can see that the person is launching some application. The scene changes for us as well, and I'll increase the speed of the application of the video. And basically, she had the scene rendered where some 3D object floats in the air that shows the wind and the navigation buttons, and uh, she's going to use those buttons, those controls to change the scene, change some wind flow or something. So basically, this is how the HoloLens is experienced by the user. Another interesting part of this video is the person that uses also the HoloLens application, and he's rendered remotely on the scene. So you can see that there is a real person wearing the HoloLens application, HoloLens device, and he's interacting with the scene, yet there's a floating figure of another person who uses the VR or XR device, and they also can see the scene. And yeah, you can see that they're interacting pretty effective. And basically there was, well, you can see that the person also interacts with the holograms that are rendered in the actual space. And yeah, he's going to take all those pictures and pin them to the wall. So you can see the useful part of how HoloLens 2 can be used, but we'll look at the business examples later. But now I want to talk a little bit about how the device works. So there's a brief history on the HoloLens, and I'm just going to tell you that on 2019, 5 years ago, was the release date of the HoloLens 2, and the HoloLens 1 was released on the 2016, and it was 8 years ago. So the technology is pretty old, and it's been a while. And basically, the idea behind the device is that it uses a bunch of sensors, like cameras and head positioning sensors. And the device uses the image projectors that generate lights and sort of throw photons into your eyes. And the waveguides diffract the light, and they are navigating the light particles into your eyes. So basically, there is no problem of having a huge brick on your head that consists of different parts of I don't know, technologies and cameras and sensors, and you can put LCD monitors in front of your eyes. There's nothing special about it, right? But the problem is that all this technology requires a special amount of electricity. It has to be lightweight, so your head will not be hurt or tired from using those devices. And the putting LCD in front of your eyes is not actually useful, because then your eyes will try to focus on the LCD display, and then they will try to focus on the reality. So the experience is not going to be as good as desired. So because of this, HoloLens 2 was built with the technology that basically has a laser, 3 lasers, red, green, and blue. Those 3 lasers decide the color of the particle or of the photon. The photon is then directed into the mirror that is moving with the speed of 12,000 times per second, which is huge. And the distance of the photons that are directed is something like 10 picometers, which is like the atom of helium is 62 picometers, and this glass is moving with the precision of 10 picometers. So the technology is pretty awesome, and it is basically done because in this way, because otherwise you had to have a huge amount of weight on your head, and like big devices that are not looking useful. So they have this technology that directs the light photons directly into your eyes. Then this light comes through a bunch of mirrors and directly into your pupils. Okay, so this is the actual picture of the mirror that is moving there in the HoloLens, and this is the picture under the microscope. The lens is super tiny. Okay, so another thing about the HoloLens 2 technology is that you have to HoloLens 2 is the mobile device, the same kind of a mobile device as your phone or your tablet. But on your phone and your tablet, you can just press the lock screen button, and then the consumption of the energy is minimized. Okay, but doesn't work for HoloLens 2. You cannot just switch and turn it on, turn it off. It is constantly working, but it has to go to the less energy consumption mode when you're not using it. So it basically leverages the AI that understands the hands, and if the hands are not positioned in front of the HoloLens camera, then the energy consumption will go down slowly, and if the hands will appear suddenly on the HoloLens camera and the AI will recognize it, then the consumption of the energy consumption of the device will gradually increase. So this is another interesting part of the HoloLens, how the HoloLens 2 made. Spatial mapping is the feature that allows to understand what is the space around the device and to pin the apps or position the apps according to the space or walls you have in the room. So basically on those two pictures, you have the image of the wall that is recognized by the HoloLens on the left, and you can see that there's a kind of hole in the wall. On the right, you can see that this hole is actually not present, and this is because the AI understood that this is a hole in the wall and some part of the data is missing. So it is the hole is covered with the mesh that is produced by the AI. And this is how the room is rendered by the HoloLens. Well, not actually rendered, but basically understood. You can imagine that this is a blanket that covers the space. So this is the single surface. This is the same single surface around all the objects. So this is how the device understands where in the room you can pin and position the applications. If you want to recognize separate objects like separate chairs or separate tables or separate persons and understand who those persons are, you can leverage Azure recognition services, AI recognition services, and embed it in your application, but you have to do it yourself. One of the features is the eye tracking. So the HoloLens can understand the eye's movement, and you can actually control the holograms with the gaze of your eyes. And the interesting fact about the human mind is that we first move our eyes, and only then we understand why we have moved our eyes. So basically, this has allowed to the HoloLens developers to implement features that basically predict what the user want to do. So in a way, this is an experience as if you wanted to scroll down your page on the website, but the scroll bar appeared even before you understood that you wanted to scroll down. So some kind of this experience is allowed because, we have this interesting feature of our brain that we understand what we want to do only after we have started doing it. So we have come to the section of the customer stories, and I have a couple of videos here prepared. And basically, this is the video of some designer studio, and there's a couple that is deciding to buy a design apartment for them, and you can see that they are using the HoloLens device to understand what is the actual looks of their future room, and then they can change the colors of the items. And basically in the video they say that the closing ratio of this designer studio has increased because of the actual experience of the users of the HoloLens. So you can see that there's some furniture rendered, and yeah, they can look at different colors of the different things. So another video comes from the Airbus, another customer story from the Microsoft. I'm going to skip here a bit, and I'm going to turn on the sound.
Of the services like Azure Remote Rendering of spatial anchors is key to give us the guarantee that we adequately use the HoloLens 2. I mean, it's key to have the right data flow. It's key to have the right rendering. It's key that the person using it finds himself or herself in the right environment with the right quality of data and therefore quality of visualization. So it's absolutely essential. The advantage of the HoloLens 2 in the design process is mostly in the validation phase, when the designer needs to know whether his or her design is really fit for industrialization. And this is hugely accelerated by 80%. On the manufacturing side, we use HoloLens 2 to enable the workers to achieve complex tasks or tasks that require an intense reading of documentation. Well, finally, they're hands-free and they can access complex areas, they can handle heavy parts while having all the information they need right in front of their eyes. So we strongly believe that mixed reality can bring improvements up to 30% of some of our industrial tasks.
Okay, so I really like this video, and I wanted to share those two videos with you. Another customer stories I have read about is the Centrica PLC, and this is basically a big energy company based in the UK, and they sell gas to consumers and in the UK and Ireland, and gas and electricity. And they have built, they have huge facilities that provides basically gas, and they have built the maintenance guides with the usage of the Azure Spatial Anchors technology. And you can see that on the bottom right, you have the picture where some technician understands that there is some kind of manual that helps him to manage some equipment. So another picture of the technician from Centrica PLC that uses the guide that floats somewhere in the air that is related to the position on the facility. And HoloLens has brought a lot of value to the Centrica PLC. Those guides are made with the precision of millimeters, so it is incredibly precise. It has reduced risks and costs by minimizing the offshore personnel. So you can understand that there's a huge facility, and you have to have technicians that are support this facility, and you have to deploy them on those facilities, probably the oil rigs or something. And they have remote support from the offsite expert to the frontline workers. So there is a technology that allows for the experts to manage the holograms on the user's device. So you can imagine that the technician is getting the live support from the expert who is located somewhere in the office or at home. And this helps to transfer the skills and to have the skills retention for the Centrica PLC. It has also the Centrica PLC has also got rid of the paper-based information processing. So you can imagine how huge manuals that are paper-based, and you have to take them offshore to understand what you have to fix and how you have to do it. And instead of this, you have just the HoloLens and the guides that are floating in the air that are related to the position of the equipment. Okay, so there are many and other stories that comes from Microsoft, from their clients, and you can see that there is a bunch of them and many more on the Microsoft website. Also, there is a Lockheed Martin company on the bottom right, and if you know, this company produces military equipment and supports and supplies the military equipment to the U.S. Military and to the NATO allies. So I want to talk a little bit about the Department of the Defense of the United States of America and their history with Microsoft. So in 2018, Microsoft was awarded with $500 million contract from the Department of the Defense to create prototypes of the devices, means HoloLens. In 2019, Microsoft was granted a $10 billion contract to supply cloud services to the Department of the Defense. In 2021, Microsoft received a contract for $22 billion over 10 years for the HoloLens devices. And Department of the Defense expects to get 120,000 devices for their close combat force. Means their stuff and basically army men. Visual augmented systems is how they call the technology in general. So their idea is not just to get the devices, but to embed this technology into the planes, into their tanks or other vehicles. So how do the military men and army men use this technology? And you can see that on the top left, there is a group of military men wearing the glasses. And on the top right, there's a map rendered with a plan on the floor. And the idea behind this technology is that this group of army men can understand the plan, they can share it, then they can discuss it, but nobody else can see it because the plan is rendered only directly into their eyes, although they can see it and they experience it as if it was projected to the floor. On the bottom right, you can see that there is a night vision version of the HoloLens. Basically, the benefit here is that usual night vision glasses render everything in the green light, and HoloLens can render the picture closer to the actual colors of the objects. And you can see that there are two figures behind the obstacles drawn in the HoloLens. So if the position of the enemy forces is understood, then the people can be drawn as a holograms. The user can understand the position of the people behind the obstacle. On the middle, you can see that there is a picture with the synthetic training environment, and the idea is basically that the military group can have a training in one environment, and then if you want to build another environment, you do not have to build it in reality. You just draw another environment, and you start another training. Okay, so basically those were the benefits. Let's get into the development of those applications. So first and most obvious way on how to build those apps is you can use OpenXR with the C++, but unfortunately this goes way beyond of my expertise. So I have decided to use Unity engine and the C# language with the usage of Microsoft Mixed Reality Toolkit. And this was the path that I've chosen. There are many other ways how to build those apps. But nevertheless, if we are using Unity with the C#, we have to anyways, we have to build our solution first into the OpenXR with C++, and then use Visual Studio to build our solution second time and deploy into the HoloLens. So there is a middle step of building those applications. You are not just building directly from the Unity, you have to first build it into the C++ solution anyways. And yeah, we will discuss the Azure integration later, but now I want to show you how the development in the Unity editor looks. So this is the Unity editor, and you can see that there are a couple of tabs. On the first tab that is called scene, you can see that we have the scene with the object and objects, and we are positioning them. You can see that there's some sounds and some buttons there, and we can manipulate them. Okay, so the other tab is called game, and here actually the scene is rendered as if it was seen by user. So you can see that there is a menu floating and following us in the air. So I can press those buttons and I hope that I will get an indicator that will point me to the to our well, this is the Mars rover. I guess this is the Curiosity Mars rover. So we had this indicator, our pointer, and I can pin this menu somewhere in the air. Yeah, I'm going to pin it one more time, and it is not following me anymore. So I have pinned it in somewhere in space. And you can see that this rover is basically, it is unassembled, and we have hints that are rendered around it on where we have to put the parts of this rover. So I can grab this this part, probably this is the camera, and I will put it in front of it. Another camera looking like part, I can put it there, and I can assemble other parts. Yep, and this should probably go here in front of it. And there's one last part left. So I guess I have to move it a little bit back, and this part goes here. And our rover is complete. So we can see that basically this is, I guess, 99% of how you would use the HoloLens device is just basically some kind of manual that helps you to do your stuff. You can see that if I will gaze at the button, then the name of the button will become bigger. Yeah, and the handle will appear. So basically, this is the gaze interaction with the object. Basically, it understands if I'm looking at something, I can manipulate those objects basically with my eyes. I can put the button, press the button, and yes, I'll just walk away a little bit, or put my hand a little bit away, so you can see that I pressed the button and the rover has been disassembled. I can reset the scene by pressing this button, and I can remove the hints from the scene, and they will disappear. I guess I can assemble the rover once again without the hints. So basically, that's it. This is the application, how the development and the application itself looks in the Unity editor. But I wanted to share the project settings also, because here in the project settings we have the plugin management section, and you can see here that we have the OpenXR here, and the Microsoft Lenses feature group turned on. And basically we have the XR tab, and here we have the Microsoft HoloLens features and other Microsoft hand Russian profiles here under the OpenXR tab. So you can see that those technologies actually use the OpenXR. Okay, so unfortunately I couldn't get my application working on the HoloLens emulator. so I didn't manage to use my applications with a bunch of Azure integrated services. And I want to briefly discuss them. Azure Spatial Anchors is one of them. So you can see that there is a picture on the bottom right, and which has the some kind of a puppy balloon, and this balloon can be seen on a number of the devices, including those headsets and probably the Android phone and some kind of iPad or something like that. So Azure Spatial Anchors basically allows you to render remotely holograms into the different devices, number of the devices. It also allows the software development kit for the Android and iOS devices. There are Azure AI services that can help understand the speech of the user of the device. There's an Azure Spatial Audio integration uh, with the Azure with the HoloLens. It basically allows to do the same stuff as the Azure Spatial Anchors. You can hear the sound that is positioned somewhere in the space. Azure Cloud Services allows you to take AI and understand the objects that are present somewhere in space. So you can understand those objects in particular, not as a single blanket that covers everything. Holographic remoting is the last but not least. It allows the experts to share their knowledge with the technicians that are using the device, and they're somewhere remote, and the experts can actually manipulate the holograms that are rendered on the user's HoloLens device. So basically, that is it. There are three questions that I have tried to answer, and the first one was, can we do it? Can our company do it? Those kind of applications, and the answer is yes. But we needed more research and development investments because I didn't get to deploy my application and work it on a HoloLens simulator. I had some problems with the air top and numerous problems with the HoloLens emulator that are basically connected to the performance and navigation. So I didn't like the HoloLens emulator. Maybe it was because of my computer, maybe because of some other reasons. I doubt that Microsoft would have released HoloLens simulator that isn't working properly. But nevertheless, I couldn't manage to work to make applications work on the HoloLens simulator properly. The second question was, what competencies are needed for the development of such applications? And well, I have numbered 5 of them, but first 3 of them is enough. Unity, C# and MRTK would be enough to create and deliver applications that has the value for the customer, that brings the value to the customer. But I have also mentioned C++ and OpenXR as those are the underlying technologies. And if you want to understand and control the application flow or the build, or to control basically all the features that are available, you have to understand C++, OpenXR, and this level of work of the applications. So another question, the last question was, how can we sell it? And there are 2 answers. We can build a prototype, we can discover business cases and share them with our clients. You can see that there is a number of business cases like manufacturing and industrial design. There's a healthcare and surgery, and basically all of them, there's a number of them and many, many more. And basically, the idea is that we are sharing the knowledge and we are visualizing the knowledge, and we enhance the user experience who are trying to deal with some complicated equipment. Okay, so basically that is it. If you have any questions and you want to get answers, you can reach me out on the Instagram. You can reach me out on the LinkedIn, and those are the QR codes to my profiles and those social networks. And yeah, thank you for your time.